What's up, guys? This is Legit Lee back again with another video. In today's video, I'm going to be showing you how I made version 2 of the Filastruder. What's going on, guys? I'm sorry that it's taken me so long to actually come out with another video. I've been doing a lot of work for other projects, but that's neither here or there. They will be coming out shortly, and at the end of this video, if you do stay on this video here with me and watch all the way to the end, I do have a lot of information that I'm going to be giving out to you guys as well. There's a lot of crazy stuff going on for this new year that I have going for you, so stay tuned for that. And if you are new to this channel, I do 3D printing. I do a lot of DIY work as well, electronics, pretty much anything. I'm really tech savvy, so if you guys haven't subscribed already, consider doing so, and don't forget to hit that notification button if you wanted to know when I put out a new video. Anyway, now that we have that information out of the way, right here is my version 2.0 Filastruder. Really, I made it super smart. That's basically what's going on here. I have a 650 watt, I believe, power supply running the whole system, and everything is being ran off of the Octopi or a Raspberry Pi with Octoprint on it, and a Ramps 1.4 board that you would normally get with the LCD controller, which is around $35 for that kit, and then $35 for the ramp. So $65 would pretty much do you good for the boards, and then another, I guess, $40 would be for the power supply. So I'm trying to make it really cheap and eco-friendly, and there's a lot of information on this as well that I'm going to give to you today. And most of these parts are recycled parts as well, so I'm going to go over everything here with you. I'm going to try to keep the videos as short as possible and go over everything really quick. So please stay with me. If you do need more information and are needing questions answered, definitely leave any comments down below for me to actually respond to you. This is open source still. Everything I have, the Merlin software, the Octopi, all that stuff is open source, so I don't mind being open with all the information about how I built this. Anyway, so let's go ahead and jump into everything. So the first thing I want to say is everything is being ran off of a web server, which is called Octopi or Octoprint, however you want to say it. And basically it's a web server that goes through your internet that you can set up for usually 3D printing. And if you need any information on that, you can definitely look up videos for it. I may be doing a tutorial on how I'm using it as well. If you guys want to see that, let me know. Anyway, so I'm running everything through the internet, so I don't actually have to touch anything. So say like I want to put this, I don't know, if I was living in up north in a basement, or down here down south in Florida where I'm living at inside of a shed or in another room where it's not making so much noise or bothering me, I can actually set it up where I don't have to control anything. If I have a hopper like this and has a whole bunch of pellets or filament in it, I won't really have to worry about watching it, because the Octopi already has an ability to watch everything through a webcam, which usually is ran by a Logitech or through the Octopi, Raspberry Pi's Pi camera basically. So you can do that also, and so you don't have to actually watch it, and then you can actually control everything through the server as well. So you can do it by the power supply, to turn on the power supply, because the system isn't fully on yet. The only reason you see this on and the Ramps board on is because it's getting power from the Raspberry Pi's USB cord. So I will in the future be changing that so nothing will be actually on. I have another USB cord coming in, which I'm going to cut into the wire and then set up a switch mechanism in it, so that way none of this will be running. So when I do shut it off and leave the Octopi running, I won't have to worry about the Ramps board being on as well, draining any extra power. I'm trying to make it as eco-friendly as possible here. So first off, I can control everything. I have 5 heater cartridges inside of a aluminum heater block that I had custom made from a machine shop. And if you've seen the other videos, you will see those heater cartridges will slide into slots that I actually drilled holes for. And then on top of the block, I drilled another few holes into that slot so that way I can use a screw to mount the heater cartridges inside of the block itself, so that way it wouldn't move any. So there's 5 heater cartridges, and all of them are being ran off of the Raspberry Pis and the Ramps 1.4 board's power source. And how I did that was very complicated. What I did was unsolder the normal hot ends actual NPN transistor off of it, and basically they look like this right here. They're little small transistor that you don't really won't really handle all this heat. It will actually burn up on you before you can actually really heat it up the way you want to. So what I mean by recycled is I unsoldered that and soldered on, these are regular Mosfets that you would get for your normal 3D printer, which I'm pretty sure you guys are aware of. They're usually around $4 to $8 depending on where you get it from. And these two right here are recycled because they had broke on me. They just stopped working, you know, circuitry, heat, stuff like that happens and they burn out on you. So something inside of the boards just stopped working, and I was just keeping them around just in case I want to use them for spare parts like I am doing right now. So right here I have this NPN transistor that came off of one of these recycled MOSFET boards. I desoldered it off of the board and then soldered it onto the Ramps board where you would have had the small NPN transistor that I just showed you to replace it so it can handle the higher heat and temperature. And then from there, like you would your normal 3D printer, you would add a MOSFET to control your heated bed or your hot end. So that's what I'm using this for. Both of them work together basically to actually work as a whole set unit, and they will stop the overheating of the cartridges and will stop overheating for their circuitry, because you don't want anything to get too hot. So really I could hold on to this and none of that stuff will actually be super hot or anything like that. So first what I'm going to go ahead and do is we're going to go ahead and turn the system on. The fan and all this, you'll see everything start turning on when I do click it on. The Octopi has a power on button source that you can get for plugins. It'll turn on the power supply, which and then will turn on this fan right here because it's hooked up to the straight to the power supply's 12-volt line. I can set it to the 12-volt line and control it through the Ramps 1.4 board, but I didn't want to do that as of yet because I want to show you guys that it will work when I turn on the whole system, because you won't see this fan on my PSU running, not the way I have the camera set up anyway, but you will see this fan turn on because this one lights up blue. So I'm going to go ahead and turn on the system now. Let's go ahead and click the little electric bolt icon. And there you have it. So I didn't touch anything but my mouse, and you can set this up for Octopi on your smartphone, whether you have iOS or Android. Either one of them will still work. So it's just like having a regular Octopi, which basically that would be completely mobile. So I turned it on the system, and then, so that's what I mean is I can turn on the system remotely. Won't have to worry about that. Then I wanted to be able to set the temperature remotely. So right now it's at 97. That's just because I was testing it out just a moment ago. It's at 97 degrees Celsius, but we all know that ABS and PLA are higher temperatures. ABS would be 230 or to 240, and then PLA would be 180 to 195 depending on what kind of filament you're running with it, what kind of PLA, and what your PLA is actually rated for. So I'm gonna go ahead and set the PLA temperature for my system here, but I'm gonna set it to 195 because that's the type of PLA that I usually print with. So we'll go ahead and hit enter right now. And there you go. You see extruder 1 heating, 195, and then you'll start seeing the temperature increase because now that light back there is basically the switch for this, telling it to turn on. And now we're going to go ahead and, while this is heating up, I'm going to go ahead and go over the information here with you. So right here I have a little circuitry going on here that I want to go over a little bit here with you. First thing is first, we have 12 volts coming out of this power supply down here. This is the 12 volt line, and then the actual positive line is coming out of there, going through the NPN transistor as well. So basically I only have one 12-volt line coming out of here, but all the other power is coming out of the ramps board. And the reason why is because this is going to be my negative side, and I have that right here. This black wire is coming out the back. This was reused. I didn't pull it off like this one was. I will probably do so later, but I just soldered onto the solder leads on the back end of the board and then had this black wire come out. So this 12-volt positive line goes up through here to this top line right here that goes to one end of all 5 heater cartridges. And then the negative line comes from this transistor or MOSFET through this negative line and goes to the other end of the heater cartridges. So both of them, all 5 are getting power from the power of the actual power supply and then the negative side of the ramps board power supply. And then this is all the circuitry for that. We have basically the gate and the open and the close, basically everything for the transistors wiring is wired through here as well. And then that is all connected to the ramps board, which this wire right here is the ramps' power from the actual extruder port 1, and then this one right here is the negative from that same port. So everything right here is set up like that. And I will, if you needed more information, like I mentioned, just ask me. If you need me to do like a diagram, I can definitely do so for you. Anyway, so what's going on here is it is literally heating up to 195 degrees Celsius, and I have ran this system to 260 degrees Celsius. That is literally, I believe, the hottest that you would ever need to actually heat this system up for anyway. So I just wanted to see what I could do with it. It was able to run no problem. I had it on for hours, literally like hours, running at 260, testing everything out, trying to make sure that nothing was heating up. Like the only things I was really worried about heating up bad would be the MOSFETs, but I literally can hold and touch them for hours on end and not feel anything. Literally, it's just warm to the touch. That's all. That's for both of them. Anyway, so a little about the whole recyclable stuff. These are recycled MOSFETs, and I'm using an electrical conduit pipe. It is a 3/8 inch pipe that I got from Lowe's, and then a adapter coupler that will adapt to the 3/8 pipe that has a threaded end on it that will actually just screw my heater cartridge block onto that pipe, and then another brass tap that's a 3/8 inch brass tap that will actually go onto the threaded pipe that I have made the whole heater cartridge basically. So the brass tap has a drilled out hole of 1.75. I literally went on eBay and purchased me a drill bit that is exactly 1.75 for filament that you use for your 3D printer, because that's the thickness of the filament. Usually anyway, it's either 1.75 or 3 millimeters, depending on what kind of printer you have, but most printers nowadays use 1.75. Anyway, so that all these parts I got from, so the pipe is from Lowe's, the adapters from Lowe's, the brass tap is from Lowe's, this pipe holder is from Lowe's as well, and I have a 3/8 bolt, I believe, or 3/4 bolt. I can't remember what the size of that bolt was. Anyway, I have the bolt going down through it, then I cut off the top part so that way it'll make it flush for the bottom part here, so I didn't have to worry about that. And then this Auger Bit is from, actually not from Lowe's, but from Harbor Freights, because they had a 3-pack for $20. But you can get one from Lowe's if you wanted to. That is a 3/8 inch auger bit that's made for drilling through walls and through like house walls, like through wood basically. And then over here, I don't think you can see it, but that shaft is connected to a window motor from an old car from a salvage yard. So I went ahead and got a window car motor from an old salvage yard off of an old car and that cost me about $25, I believe, and was able to run the system off of that using the 12-volt rail lines. That's why I would want to get this set up for 24 volts, just because of that. The speed of it is not as fast as I want it to be, so I will be upgrading the power supply to this. But for the most part, the 12-volt system does work. I mean, it's able to heat up, but a 24-volt power supply would be able to probably heat this up quicker. For me to get up to that the 195 usually would take about, I want to say, a good 20 minutes or so. It takes a little while because of the fact that there's so much pipe to heat up over here. I mean, there's just, it's just so fat that it takes some time for it to heat up the whole entire thing, but it will heat up and stay there no problem. But so for this information, what I wanted to get over here with you is the thermistor next. The thermistor I got is one of those 3M millimeter bolt looking ones. It's not the regular one that you have to put a bolt to and then like you stick it in a little hole and you put the bolt into it. It is literally a bolt that is a 3 millimeter bolt that will go into the whole actual system here. So my heater cartridges are mounted inside of that aluminum and hot end that I made, and then the thermistor is actually a bolt that's bolted into the hot end as well. I drilled out a hole and then threaded it myself. And then after I threaded the bolt inside of there, I ran the wiring. You can see it right here. This is the wiring coming out from that bolt that reads the temperature for what the temperature is currently at. So other than that, this right here is just a regular washer that is pushed up against the auger bit, and then I have a actual bore that's on there mounted to the pipe that has a screw and lock. It's basically like a locking mechanism to keep it from moving. And then I have a thrust bearing that's pushed up against all that, so when it spins, it'll just go on the bearing and just spin in circles. And then other than that, I have about 5 washers right here that's pushing up against this. It's just a little socket, and then the socket goes into a regular 3/8 socket that you would have. This is a smaller socket, and then there's an adapter onto it that goes straight onto the shaft of my motor. So with that being said, everything here is going to be able to be smart controlled. So if I wanted to heat it up from downstairs, I can do so. The only thing that I would actually have to do and touch on this system would be the actual pellets or plastic that I'm going to be recycling. Eventually it will run all the plastic out, and then I'll just have to fill the hopper back up. But it is working great. It does take, like I mentioned, it does take a little time for it to update, to heat up, but it definitely will do so. I'm going to make a better enclosure for this. That's why it's mounted on all this wood. It will be encased and everything will look really nice when I'm done with it. But this is still beginner stages. I still got to get that 24-volt power supply, so I can remove this one here. I would like to 3D print me some parts that'll attach to the fan so it'll cool at a specific location for when the filament's coming right out. I don't want to have to worry about the actual filament staying too hot. Now, what my intentions are for this system is I'm going to literally be recycling plastic bottles that you would normally use for like drinking water. So like say a 24 pack from Walmart or something like that. I buy Zephyr Hills water because I like Zephyr Hills and spring water. And what I want to do is chop the bottles up, put it in pieces inside of the hopper, and then extrude it out the end and be able to use it as recyclable filament, just like you would at just like the corporate industrial plants do whenever you get PETG, the filament. I'm going to be doing the same here, and there's a lot of crazy stuff that you can do with this. So just going off a few of them, you can recycle plastic materials that you normally would use. So like any of your PLA or ABS that you are using to print, like the supports and everything, can be reused through the system. You will be able to actually mix different types of filament together. So if you wanted black and red, you can mix those two together. And I want to be able to use different types of like filament mixes. Basically, I'm going to be mixing a lot of my own filament and creating my own. So I'm going to be using like flakes that you would use for like cars, that they paint with flakes on the car to make it shiny and sparkly. I can get some really fine flakes, mix that in with the filament, so when it comes out, it'll have like this little sparkle and glitter inside of the filament also. So you can do a lot of that here, and I will be going over a lot of that information as time progresses. I have some machines already here to help recycle and break down the bottles here, which is really easy and easy to get a hold of. That helps you do so. I'll give you the information on that at a later date as well. But for the most part, guys, this system works great. I like it. Spent some hours on it, just piecing and putting stuff together, but I finally got it working pretty well. And just to let you guys know that the plastic bottle version of it does work, I'm going to pull a piece off of this brass tap that you see with these little pliers that I got right here. And I'm going to grab that piece. And here you go. This little piece right here is actually me already recycling plastic bottles. It turned out gray because I had the actual temperature way too high, so I had to dial back the temperature on it. I read up on Google that the temperature for melting down polyurethane was 255 degrees Celsius, so I started off at that and started dialing it back. And for plastic bottles, it seems like around 230 something, or maybe even 195, around there. I haven't fully got a chance to go over that. I will be doing so in the future about where is like best to melt plastic bottles at. But for the most part, the 255 is way too hot, and it starts to turn and burn. Well, it melts, but it turns out gray for the plastic bottles instead of that clear look. It may not be fully clear when you are doing it. It will definitely be a lighter gray, if anything. Not this dark. This is basically like gray filament to me right now. But I literally pulled this piece off of it, so it does work. And right now it's at 183. So also what I want to go over, since the system is running off of a 12 volt power source, I have this speed controller right here. This is rated for anywhere from, I believe, 0 to 55 volts or something like that. I can't really remember the exact voltage, but I won't be using that much voltage anyway, so I'm not worried about it. As long as it could do 12 to 24 volts, that's all I really needed it for. But once I get everything set up, the system is not going to even need this. I'm just using this for right now. But the system will be able to just turn on. It'll literally just give 24 volts straight to the motor to start spinning at the highest RPM, so that way I can speed up the filament coming out. So I'd rather just go ahead and start off high once the system is fully heated. So this PWM is just to see. I was just testing out the speeds and what the best speed is at proper for this. What's the best speed? Basically the speed setting for the system. But it seems like the faster the better, because then it will produce filament faster. And then you can do it the other way if you want to just use a speed controller if you want to, but I probably won't be doing so. And even with that, you can definitely change the speed through the system also through the Octopi, because you have the ability to change the PWM through your settings and everything like that if you go that route, which I may do a video on that as well if you want me to. But for right now, we're just going to go ahead and turn the system on. So I'm going to spin the system. And there you have it. So it's running really slow right now, but it's just because the filament in there is spinning, and it's just running slow right now, but it will speed up once the filament starts getting at a higher temperature. I mean, 192 is still pretty good, but there's a lot of melted bottle basically, and that's not the temperature for it. It needs to be hotter, so it's not going to spin as fast. It's still kind of clunked up in there, but once it does get up to the higher temperature, it definitely will start spinning faster for you. And then once that happens, you'll be able to get your filament to come out as much as you want, as fast as you want, however you want to go about it. I do think this system is definitely something for anybody to check into, anybody in the 3D printing world or community. This is something really amazing. I mean, literally, they have them out here for people to buy. You know, obviously it's called the Filastruder, but those systems are super expensive. You spend anywhere from $3 to $4 to $1,000 for a setup if you had the money. But this right here, I mean, the ramps board is what, $35. The Raspberry Pi is like $35. So we're set $70 just for the board. Another like $30 for the power supply. So now you're at you're at $100 right there. Then the motor to run the system was $25. So $125. Then the Auger Bit was $20. So now we're at $145. Literally around $200 will get you a smart controlled Filastruder, because with all the miscellaneous pieces like the the pipes and everything, I would say around $20 to $25 probably would set you up nicely here. And that's if you're trying to go this route. If you're needing to spend more money, then you could definitely make it even better than this and do a whole lot more, like lighting and all kind of crazy effects. But this system is literally going to be an amazing controlled system all on its own. It'll do everything you want it to do and then some, and you won't have to worry about anything. And you hear the motor kind of already spinning and increasing in speed because it's still heating up. So now it's at 195, and I could change the temperature to whatever I wanted at. I literally had it running for 260 degrees for a few hours before. So now that it's set correctly there, and this video has only been about 8-9 minutes or so, and that's how fast it heated up there for you. So let me go ahead and change the temperature now. We'll change it to let's just go ahead and do like 205 or something, or 220. Let's just do that. Okay, so we have it set for 220 now for the system. I'm gonna go ahead and press enter, and there you go, 220. Now it's heating up again, and it's still spinning. It's gonna do what it needs to do. So I mean, I hope you guys are liking this video. I try to be very educational for stuff like this. I do have a Raspberry Pi Zero here, and I was thinking about using it for the system to make everything really small and compact. But the system's already going to be big because of the power supply that's needed to run it, and then all the electronics are just pretty much in this general vicinity, so I wasn't really too worried about it. And then like this whole setup right here is going to have to stay that way, obviously, to run everything, so I can't really make it any smaller. But adding a Raspberry Pi Zero with basically Wi-Fi and Bluetooth built into it would definitely make this system a whole lot smaller, because this will be your server. But right now I'm just using this one because it has the pinouts that I needed, and I'm able to run it I feel like more efficiently with a bigger Raspberry Pi. But I may change it in the future. It's all depend on how I want to go about it. Other than that, I have the fan running. I 3D printed this piece myself. I 3D designed this piece that'll mount to the actual 2x4, so it blows all the cold air up through the filament, and so when the filament comes out, it cools it kind of quick. And then there's a bar right here. I don't know if you guys can see that. I'm going to try to turn the camera just a little bit so you guys can see this. Basically, this bar that I've designed, it has a rod on here that'll mount, say, like a pipe, like a brass or copper or anything like that, something really slick and smooth and shiny that'll allow the filament just to flow over it so it won't touch the fan itself. And it's all adjustable because I have it on these threaded rods right here with some nuts, so I can bring it up if I needed to, bring it down if I needed to, however I wanted to go about it. So everything is really adjustable here, other than you know, actually everything, pretty much everything is upgradable. Also, if I wanted to get a bigger LCD, I can go with the full graphics display if I wanted to. Anything that your 3D printer can be upgraded to, pretty much the Filastruder 2.0 can be upgraded to. I hope you guys are liking this video. Please like, subscribe, hit that notification button if you guys want to know when I put out my next videos, especially about this system here. I have more videos coming. And now that you made it to the end of my video here, I have a special announcement for you guys. I'm literally going to be going to KamehamehaCon. I bought my tickets. I hope you guys are excited. I'm excited to be there. This is the first ever KamehamehaCon that I'll ever would be going to. And I'm going to be 3D printing and doing a lot of crazy stuff with Goku, the Vegeta, all kind of crazy stuff's about to start happening. Just to give you a little preview, I made this right here, 3D printed this whole entire thing. This is Ultra Instinct Goku. It is actually clear PLA as the base, and then I have black PLA as the top. I stopped the actual printing on the printer, and then started it after I changed out the filament, so you can kind of see it. It's two-toned. The top layer is black, and then the bottom layer is that clear filament. And it looks really great. I 3D designed this piece myself. This is pretty amazing. I really like it. And the way I designed it is I put some grooves inside of the actual corners, so I can mount some RGB lights inside of it to light it up to make it look really nice. It's kind of like a picture frame, but this is actually going to be used in another project, which is going to be coming soon to you as well. I have about probably a good 10 to 11, 12 maybe projects going on, and I still have a lot of ideas that still pop into my head that I want to make. And I literally had to start writing everything down because I have so many ideas and projects that I want to do, that I will do, that I had to write down for. So this is going to be for another project. I hope you guys like this. And if you guys are going to KamehamehaCon, let me know. We can get together, do a video there with you, shake your hand, get involved with you guys. I'm here for you. Any information you guys want about anything, I'm here. Message me about anything. I don't mind at all. I'm here to help you guys to figure out how I made all of this possible. And I will be doing cosplay outfits as well. That's going to be on these next few episodes also, so you'll start seeing more videos of me designing some crazy stuff for KamehamehaCon, which is coming up in the next month, so stay tuned for that information also. Other than that, I'm glad that you guys stayed to the end. You guys are freaking fantastic. I'm glad that you guys are still watching my stuff and subscribing. I will be doing giveaways also. I'm probably going to be doing a giveaway of a t-shirt that I'm going to design with 3D printing. So if you guys are going to KamehamehaCon and I see you there and you guys come talk to me or whatever the case may be, I may just give you the shirt off of my back, literally. And so stay tuned for all that stuff coming soon. I'll have a lot of video, guys. Lots of videos coming out for tech gear reviews, 3D printing, 3D designing, and filmmaking also, because I do like making videos. So my films are going to start looking really good as well. You guys are fantastic. Thank you for staying and watching till the end. And if you did, like I mentioned, let me know any information you want. I'm happy to give it to you. You guys are great. Thank you for watching, and I will see you in the next one.